Greetings, students. If you struggle to understand factor label method, there are other ways to do mass-to-mass stoichiometry, so this video is made for you. That being said, this video is meant to correspond to Unit 7.2. However, I will be going over some information that is in 7.3 on volume conversions, because the methods used here can be used with conversions with volume. It just requires a slight tweak to how they're done. So in this video, let's not do factor label method, and let's instead do a table in order to solve some stoichiometric problems. Table logic will work if you set it up like this. So for some table logic, we're going to set up our reaction at the bottom, a conversion between our reaction and what we are given. Conversions are things like the number of grams in each mole, or the number of liters for each mole at standard temperature and pressure, or the number of atoms, but we aren't going to do that just yet. Our conversions are those numbers that go with converting from grams to moles, our molar mass, or liters to moles, that 22.4 liters is 1 mole at standard temperature and pressure. So these numbers can change depending upon the substance in terms of molar mass, talking about grams, or if we're talking about a gas, it will always be 22.4 liters for every 1 mole. So if I want to know how much carbon dioxide is produced from running a propane tank, I'm going to start with what I'm given. I'm given 48.6 grams. In order to make any stoichiometric thing happen, you have to be in moles. The way our table works is that when you go down, you will divide by the number below. When you go up, you'll multiply by the number above. So if I am given 48.6 grams, I'm going to first fill in my conversions, since I am talking about grams and the question wants to know about grams of carbon dioxide. These are the only two players I'm really interested in, so I don't need to know about water or oxygen. They are not part of this problem. The conversions we see here are between grams, and it's always between grams and moles. Moles are tiny scurrying animals that burrow under our equation, so you need to get to moles. So between grams and moles is the molar mass of a compound. So you'll grab your periodic table, and in this space we'll put the molar mass of propane, 44.11 grams for each mole. We'll also put the molar mass of carbon dioxide, which would be 1 carbon and 2 oxygens, so 44.01 grams for each mole. So as we go down, we'll take our given and we'll divide by the molar mass, and then we'll divide by the coefficient in front of what we're looking at. So 48.6 divided by 44.1 divided by 1 is 1.10. This is our mole, and it can burrow underneath of our equation until we want it to come up. In this case, we want it to come up at carbon dioxide. So when we go up, we multiply by the numbers. So we're going to first multiply by 3. 1.01 times 3 is 3.03. We'll multiply now by 44.01, giving us 145.5 grams of carbon dioxide, which would be our answer, because the question wanted to know how much carbon dioxide is produced from this reaction. If the question was different, if the question instead had asked how many liters of carbon dioxide is formed, the only thing that changes here is our conversion. Liters and moles are connected by that 22.4 at standard temperature and pressure, 0 degrees Celsius and 1 atmosphere. 1 mole of any gas occupies 22.4 liters, in which case Now we will multiply our mole 1.1 times 3, giving us 3.3 times 22.4 for a total of 74.0 liters of carbon dioxide produced. A mole table can work just as well as your factor label method. Hopefully, this helps you with your stoichiometry.